Another possibility is to use a normal table. Now, every statistics book that I know of gives you a normal table. The format of those normal tables can vary across books. I've set up an Excel spreadsheet to mimic the tables that you'll find in Chapter 7 as well as in the appendix of Siegel. Now, what you have in this normal table is essentially a cumulative distribution function. If you go back to frequency distributions, what you have are a bunch of values of the variables. These are the z's, and then you have the cumulative probabilities. So, for example, if we go down here to, say, -3, this is just the probability that you have a z less than -3. So it's just that cumulative, like the cumulative percents that we've seen many times over when we looked at frequency distributions. So there's 0.0013 chance that you get a z less than -3. Okay, so if we want to find the chance of having something less than -1.2, all we do is go up to our z value. Here's -1.2, and we can look up the value. So it's 0.1151, and recall that's exactly what normdist told us the answer was. Okay, so option 2 is you just go over to Excel, look up the z value that you found, -1.2, and you're done. The third way of doing this is to use normdist. Now the difference between normdist and normsdist is that normdist will find tail probabilities for any distribution. And in fact, it does it exactly what we just did. It converts it to a z. But let's just try this. Normdist, and you'll look here. It's going to give you some help. So what is the x value? The x value is 38. Next, we have to tell Excel what is the mean. Well, the mean in this case was 50. Standard deviation was 10. The last argument asks whether or not we want a cumulative distribution. So this is just the cumulative, like those cumulative percents. So we say true, yes, I want a cumulative distribution, and we get the exact same answer. If I round this, let's just round that. So you get 0.1151. All right, so that's how we find the probability of a left tail. So whenever you're asked what is the chance that x is less than something, either use normdist, convert to a z, use a norm table, or use normsdist. Let's go on to the second type of question. So the second type of question is, tell me the chance of being in the right tail. Okay, well, there are two ways to do this. The normsdist function, or a table in the back of the book, only answers less than questions. So what we're going to do is use the complementary rule and just rewrite this 1 minus this. So let's go take a quick look at this with the example problem. So the next problem is find the chance that a test is greater than 60. All right. So let's go do this. Chance that x is greater than 60 is exactly the same as the chance that I have a z greater than 50 minus 60 over 10. Now if you do the math, that's 1. Now that 1 indicates that 60 is one standard deviation above the mean. All right, so that should make complete sense to you. It's just one standard deviation above the mean as shown on the graph. Now, how are we going to find this area, this shaded area? Problem is, normsdist and the table only answer less than questions. So the way we do this instead is we're going to use the complementary rule. So if we take 1 minus the chance that z is less than 1, we'll get the answer. So let's go type that into Excel. Just try it out. So if we type 1 minus normsdist, the value 1, we get 0.1587. Let's round it correctly. 1587, and you'll see that's what I got earlier. So that's one possibility. Another possibility is you just go to your normal table, and so you'll see that the z-value for 1 is 0.8413. If you take 1 minus 0.8413, you'll also get 0.1587. Okay, now there's another possibility, and that is to invoke symmetry. So here's the notion behind symmetry. This area, so the chance that you're 1 standard deviation above the mean or more, is exactly the same thing as being less than minus 1 standard deviation. So if I go look up minus 1, let's go do that. Norm S dist minus 1, you'll see that you get exactly the same answer. All right, so either of these are correct. I just noticed this number is incorrect. That'll be fixed in 1 minute. But this number is correct. Okay, so in summary, if you want to find the area in a right tail, you do one of two things. You either take 1 minus the complement, or you invoke symmetry. So I call this the double flip. You change the sign of the z-value, and you change the sense of the inequality. So that greater than becomes a less than, the positive one becomes a minus 1. So either of those things, either of those approaches will work. Okay, so that's how you find the area in a right tail. Now let's talk about slices. So slices are where you want to know the chance that x is between two numbers. So I'll go draw up an example. So for example, what is the probability that some test score is between 32 and 60? So I've shaded it. Here's 32, here's 60. We want to find the area of this slice in the middle. At this point, perhaps it makes sense to go draw it. So I'm going to go over to my sketch pad for a second, and let's just draw it. Oops. Let's try that again. So here is a normal curve. The mean is 50. And let's see, we want to know the chance between being between 32 and 60. So out here is the value 32. Somewhere out here is 60. And what we care about is this whole area in the middle. All right, well, we need to do something to rephrase this question, this question of being in that slice, as a series of less than questions. Okay, so let's start with this. First less than question that we could answer is simply, what is the chance that we're less than 60? Now I'm going to label this chunk A for now. That's fine, but we've counted this tail and we don't want to. So how can we get rid of the area in that tail? Well, the way we get rid of that area is we will take another less than question. So what's the chance that we're less than 32? And I'm going to call that chunk B. Now, the area between 60 and 32 is what we want. And so if we subtract area A from area B, we will get the answer. Okay, so in summary, to find the area of a slice, what we're going to do is find, the chance that we're less than the larger number, subtract off the chance that we're less than the smaller number. Okay, so that's exactly what I've done. I've rewritten this as the probability that x is less than 60. That was my A chunk, minus the chance that x is less than 32. That was my B chunk. Now what do I do? Well, I just repeat the two things I did earlier. So 50 minus 60, this is 1 standard unit to the right. This is 1.8 standard deviations to the left of the mean. I go look those two numbers up, and I'm done. All right, so the area in that slice is about 80%, 80.5%. So that's how we find the three probabilities in the middle. So either the left tail, the right tail, or the slice. There's one other task that we're going to have to do along the way. And the way I think of this task is it's kind of what we've just done in reverse. All right, so what we've just done is I've given you an x, and I've said, go find the area in the tail. Now what I'm going to do is say, I'm going to give you an area in the tail and ask you to find the x. For example, what is the 95th percentile? So in essence, what that's asking is find the x value such that 95% of the area is to the left of that value. So the probability that x is less than some number question mark must equal 0.95. So we're just doing what we did in reverse. So there's a couple ways to do this. One way is to use the norm inverse command in Excel. So if you type in norm inverse, I want 95% of the area given a mean and a standard deviation, you'll get the answer. So 66.45 is the answer. So what that means is 95% of these test scores will be less than 66.45. 10% will be greater than 66.45. Here's another approach if you want to do it more by hand. So let's go back to this equation up here. So the chance that x is less than some little x, I'll put little x instead of question mark, must be 95%. Let's convert this to a z now. So let's take x minus 50 divided by 10. And this thing, this number is going to get me to 95%. Let's go over to the normal table for a second. And I'm going to just scan down the probabilities until we get to 95%. And so let's see. 1.64, you'll see gives us a number just below 95%. 1.65 gives me a number that's just above 95%. Okay, so the 95th percentile has a z-value somewhere between 1.64 and 1.65. The 95th percentile is so commonly used, I actually know it's halfway between them, 1.645. So that's where I'm getting this number. So this number is coming from that normal table. So this quantity, I need to solve for x. This whole thing has to equal 1.645. And if we do that, notice we get 66.45. And that's exactly what the norm inverse function gave us in Excel. All right, so now I suggest that you try some problems on your own in Excel.